All right, so we're going to solve right triangles, and when it says solve the right triangle, that means you're going to find every missing side length and every missing angle. And the most important thing that you guys need to memorize is SOHCAHTOA. How you spell it matters, all right? So you have to know that in order to solve any of these right triangles. So we're going to use SOHCAHTOA to find missing pieces. All right, there is one thing that we can find in this triangle where we don't need SOHCAHTOA. So does anybody know which piece we can find without SOHCAHTOA, Raina? Yeah, angle B, right? Because we know this is 90, this is 35. So to find angle B, B is going to be equal to 180 minus 90 minus 35 degrees. So what is angle B, you guys? 55 degrees. Okay, awesome. Thanks, guys. Okay, 55 degrees is angle B. Now, you can use either the 35 degrees or the 55 degrees to solve. I like using the base angle. It really doesn't matter, though, all right? Let's say I use 35 degrees. Okay, we're going to use 35 for SOHCAHTOA, so we can find X and we can find M. So the first thing we need to do is we need to be able to label each side of the triangle. So this 14 is what, you guys? This is the H, the hypotenuse, all right? And then this 35 degrees, if we're talking about that angle, then X is what to the angle? Opposite. And so M is next to the angle adjacent. So I have the hypotenuse, the opposite, and the adjacent. So now we can set up a trig function. We have to use the 14 that we know, all right? So let's say I want to solve for X. I want to solve for X. So X is opposite, and then we know the 14 side, which is the hypotenuse. So which trig function uses opposite and hypotenuse? Leo? Yes. So sine of 35 degrees is equal to opposite, which is X, over hypotenuse, which is 14. Also, I just walked around and some of you guys haven't drawn the triangle. Okay, so now sine 35 equals X over 14. I want to get the X by itself. So I want to get rid of this 14. How would you guys get rid of that 14? We're going to times both sides by 14. So now I have X by itself. And we can put that whole thing in our calculator in that order. Okay, the order matters because the angle we're plugging in is sine of the angle, and then we're timesing by 14. So 14 sine 35. This is a good way to tell if your calculator's in the correct mode. If you get a crazy answer that's not like anyone else's, your calculator may not be in degree mode, and it has to be in degree mode because we're talking about 35 degrees. So anybody get an X answer rounded to 3 decimal places? Leo? You guys agree? All right, so the length of this side is 8.030. That makes sense because this is 14, right? So make sure it kind of makes sense. All right, now I want to find M. I want to find M, and I'm still going to use the 35 degrees. And we still have the hypotenuse that we know. You could use X now, but it's going to be a little bit more rounded. So I like using the 14 to get a more exact answer. So if I use the 14 side, and I want to find M, which trig function uses A and H? Cosine. So cosine of 35 degrees is always equal to adjacent over hypotenuse. So the adjacent side is M, and the hypotenuse side is 14. Okay, so that would be from the adjacent over hypotenuse, if you missed that last week. All right, same thing. We want to solve for M, so I'm going to multiply both sides by 14, and I'm going to plug that into my calculator. 14 cosine 35. And somebody besides Leo, tell me what you get rounded to 3 decimal places. Sam. Good. Rachel? Yeah.
But it's in degrees.
Another triangle. So you guys draw this one on your paper. Use trig functions as necessary to find the missing parts of these triangles. So you guys, every time you do one of these, you need to write SOHCAHTOA in your box. All right? Because I need to make sure you guys have to memorize that. Okay, so write that in your box anytime you're solving one of these triangles and you're using SOHCAHTOA, which should be every time. We should probably have a variable here because we do need to find that missing angle. So we have to find every missing angle and every missing side. Do we need trig functions to find the missing angle? Not in this one, but we could use a trig function. So this time, you guys, I'm going to use a trig function to find the missing angle just for fun. Okay? But let's start by finding y and h using this angle that's down here, 21. So let's label all the sides. So Ethan, h is what side of the triangle? The hypotenuse, so I'll just put another h there. And Riley, the y is what side of the triangle according to this angle being here? Nope. This is opposite the angle, so this one's opposite. Okay, and then down here, Ian, what side is this side down here? Adjacent. All right, so we have our opposite the angle, right, because it's right across from it, and then our adjacent, and then our hypotenuse. Okay, and I want to find, let's start with finding y. So if I want to find y, first of all, we cannot use h like we did last time because it's a variable. So we have to use the 6.4 down here that we know. Always have to use one side that we know. So Landry, which trig function should we use to find y? Yes, the O and the A, TOA, is the tangent. All right, so tangent of 21 degrees is equal to opposite, which is the y, over adjacent, which is 6.4. And we're going to solve it like we always do. So I'm going to multiply both sides by 6.4 and by 6.4. So plug this one in, 6.4 times tangent 21. And Anna, when you get it, tell me what you get. Good. 2.457. All right, now we need to find the h side, the hypotenuse side. And we're going to go with what we know, which is this 6.4 again, using the 6.4 and the 21. So Dan, which trig function should we use to find h? Tangent would not get us the hypotenuse. Is there an h in the tangent function? No. So cosine? Let's see. Yes, I think cosine would work nicely because we are using adjacent, which we know, over hypotenuse. So let's go cosine of 21 degrees is equal to adjacent over hypotenuse. All right, this one's different, so everybody pay attention because notice the variable is in the denominator. So you can't just multiply by 6.4 and solve it because that wouldn't get it out of the denominator. Does anybody know what I could do to get the h out of the denominator? Nope. Okay, so what we're going to do is we're going to put this over 1, and we're going to cross multiply. That's just going to get the h out of the denominator. So 1 times 6.4 is 6.4. And cosine 21 times h, we're going to put the h in the front. So h cosine 21. Now we want to get the h by itself. We actually have to divide by that entire trig function. So now I'm going to divide by cosine 21, and I'm going to divide by cosine 21, and those cancel. And now h is actually equal to, instead of multiplying, it's division. 6.4 divided by cosine 21. So if you guys would put that in your calculator and tell me what you get for h. Sam? have not found is the missing angle. Now that we know every single side, we can actually find the missing angle by any trig function. But we have to relabel our triangle. Okay? Because now I'm trying to find angle x. So if I want to find angle x, that changes which side is opposite and which side's adjacent. Hypotenuse stays the same. Okay? But let's look here. So the 6.4, Caden, is now what to this angle?
Opposite.
Yes. Now this is opposite, and the y is adjacent. All right? And we can use any trig function we want. So, Olivia, just pick your favorite. Which one would you like to use? Okay, we're going to use sine of x. That's what I'm trying to find. The angle goes inside the trig function. So sine of x is equal to. Now, because she picked sine, we do have to use certain sides, right? So sine, is equal to opposite over hypotenuse. So opposite over hypotenuse. So I have to write that fraction. So Chloe, which side is opposite? The 6.4. And we solved for h a minute ago, right? So Nate S, what is h equal to? So we're doing opposite over hypotenuse. What? Yeah, Nate S. So it's over hypotenuse, and we just solved for h, right, in our last step.
Yeah,
so that's going to be 6.855. Good. Good. All right. Now, we're trying to find x. So we learned this last week, and if you were gone, you should definitely watch the video. So what should I do to now get the x by itself? I want to solve for the angle, so I want to find the x. Anybody remember? Sam? Yes, the little -1 thing, which means inverse sine, okay? And then that has to go in front of this fraction here. This cancels out the sine. So now x is equal to the inverse sine of this whole fraction, and you can plug that whole thing into your calculator like that. And somebody round to 3 decimal places, tell me if you get a nice angle. We may not. Leo? 0.00 what? Did anyone else get the same thing? Okay. Now, let's think about it really quick before we actually settle for that answer. That's a rounded version. There is actually an exact answer because what do these angles have to add to? 180. So what's 180 minus 90 minus 21? It's 69. So 69 is the exact answer. The reason we got a little off is because we used a rounded value for h. Okay? So, just so you guys can see why. Yeah, Sydney? Oh, I would use triangle sum for sure. But there are times where you do have to do it that way, like on this one. So that's why I showed you. Okay? So let's take a look at this triangle. Go ahead and draw that right triangle. All right. Use trig functions as necessary to find the missing parts of these triangles. So this time we cannot use triangle sum because we have 2 missing angles. We can after we find one of those, right? But we need to find at least one angle in order to find the other one. And P, there's actually 2 ways to find P. Well, more than 2 ways because there's a lot of trig ways to do it. But if we don't want to use trig for P, what's another way to find P? Pythagorean theorem. So let's just find P by Pythagorean theorem. So 8 squared plus 12 squared is equal to the hypotenuse squared. So I have 64 plus 144 is equal to P squared. And so that's 208. And then we're going to square root it. Okay, and we should always simplify the radical. Okay. So that's actually 4 goes into that 52 times. And then 4 goes into 52 13 times. So since I have the double 4, that comes out as 1 because the square root of 16 is 4. And so we get 4 root 13. If you used trig, you would definitely get the decimal answer of this, okay? So if you were going to use sine or cosine or tangent to find that, well, you'd have to use sine or cosine because it's the hypotenuse, okay? All right, so now let's find a missing angle. First, we need to label all of our sides of the triangle, and let's decide which angle we're going to solve for first. Doesn't matter, Chloe, which one do you want to find, x or y? Okay, so we're going to start with x. So if we're finding x, now we have to label the sides according to where that angle is. So Rachel, this side is the hypotenuse, okay? And Jordan, 12 is what to the angle? Opposite. And so Leo, this side is adjacent. All right. So if I want to find x, we can actually use any trig function now because we know all 3 sides. So Hugh, you pick, what's your favorite trig function? Cosine. So cosine of x, you have to put the angle you're talking about there because we're solving for it, okay, is equal to, so cosine, so Bailey, what over what? Very good. Adjacent over hypotenuse. So Sydney, what do I use for adjacent? Good. And Sam, what do I use for hypotenuse? Good. You do not have to rationalize that because we're solving for the angle, so we're going to just get a nice decimal. All right, so Stephen, I want to get the x by itself. How do I get rid of the cosine? Cosine inverse. Inverse cosine is how we say that. Inverse cosine. All right, so x is equal to the inverse cosine of, and you can just plug that whole thing in your calculator just like that. And somebody tell me what angle you guys get for that rounded to 3 decimal places. Olivia, did you get it? Three, 2. Oh, do you guys agree? No? Leo, what'd you get? Oh, that's not right. Anyone else get something different, though? 56.32? You got the same thing? Okay. I got 1, but maybe I'm wrong. Is it a 1? Okay. Okay, 56.310. All right. Do we need to use a trig function to find y? No, let's just use triangle sum. Y is equal to 180 minus 90 minus 56.310. And so after we subtract, we should get 33.69. Degrees. Okay? Again, if you're solving for the angles, make sure you have the degree sign. So 3 answers here. We had 2 missing angles, which we found, and we had the missing side right here, P, which we could have used a trig function to find. Okay? So let's see if we can solve these on the whiteboards.